And you can probably figure out that if we did the solutions of the systems, infinite solutions again would be shown by this, zero solutions would be shown by this, and infinite again in the final row of the matrix. It's worthwhile reflecting on what kind of equations could lead to this behavior. You can quickly make some up, such as this. You may remember from yesterday's videos, the normal vector of this would be 2, 1, 1. The normal vector of this would be 1, 1, 1. So of course these two planes will be going in different directions. That means they have to meet in a straight line. Whereas here, the two normal vectors are parallel. It's just that because these are different, they each contain a different fixed point. Remember, the right-hand side is determined by the fixed point and the normal vector. So they would have to be parallel. And coincident just means it's basically the same equation, but in disguise. So anything that's satisfied by this equation is satisfying this equation as well. It's the same thing. 3 planes in space. There are 8 different scenarios. You might want to pause the video and see if you can sketch the 8 different scenarios for how 3 planes can be graphed together. Pause the video. Here they are. So it doesn't take a lot of imagination to figure that in these ones there are infinite solutions, and in these ones, the red ones, there are 0 solutions to the system. And in chapter 3 we called that inconsistent system. It's impossible to find one position that is on all 3 planes at the same time. Even though in a situation like this, if we take 2 of the planes, we can find the equation of the line. But all 3 together, we can't find a point on all 3 planes, like we did here in the previous video. There's one unique solution. Okay, so let's have a look at this example. Show that the intersection of these planes is a straight line. Well, we have to try and solve the system. So pause the video, see if you can fill in the boxes. Pause the video. There's the answer. So the final row tells us that there are infinitely many solutions, because the simplest way to deal with this is to say, in this row, if I let z be any lambda real number, then by substituting that in this row, I can determine that y is 4 lambda minus 1, just by rearranging it. And then by replacing this and x and y in this row, I can find that x is 1 minus 3 lambda. These are parametric equations of a straight line, which I can write like this. And I think if I go here to autograph, I've got that one. Those are the 3 planes. And if I just try to remember what that is, yeah. So if I go here and enter the equation 1 minus 1, 0, minus 3, 4, 1. You can see the line right there. Hope you can see that. Nah. Line of intersection. Okay. Then example 50. Show that the intersections of these planes is the empty set. Does this mean that the three planes are parallel? Explain. Okay, well, I'll give you a moment to fill in the matrix, so just pause the video. Okay, there's what you should have. So the final row, 0, 0, 0, 9, is telling you 0 times z is 9. That's impossible. So there is no intersection point of any description of these three planes. Does this mean the three planes are parallel? Well, no. If they were parallel, the normal vectors would be parallel. And look at them, they're not. Normal vector here is 3, 2, 1. That can never be parallel to 1, 1, minus 1, etc. And that cannot be parallel to this. So the intersection of the planes is the empty set, but the three planes are not parallel. So if I go back to here, it's not this one. In fact, it's not this one because no pair are parallel. It's not this one, it has to be this one. Okay. Now, we can find the line of intersection between pi 2 and pi 3. I think that's what I've done. Yeah, okay. So here's the process. You take this as a system, you eliminate one of the variables, z, and you solve for x. Then you take the same system, this time you eliminate y, and you solve for x. Then you've got x equals this and x equals this, so all three of them are equal, and therefore you can write it as a Cartesian equation, which can also be written in this form. You should try the same exercise, but for pi 1 and pi 2. And pause the video there, and I'll show you the answer. That's what you should get for the equation between pi 1 and pi 2. If I go to this example 50, here's the three planes. You may see that they make a kind of a triangular prism. I'll just do one of the lines of intersection because I'm running out of time here. The one I did was 0, 11 over 6 minus 7 over 6, 1 minus 4 over 3 minus 1 over 3. Okay, and there's the line of intersection. I will email this to you. You can try to fill in the other lines of intersection. And now you can also do this homework. Okay. Sorry that's a bit long. I've tried to keep it shorter than 10 minutes.